Hey there, Mr. Thayer from the Syracuse Academy of Science and Citizenship, back with another math lesson. Today we are tackling Module 5, Lesson 20. Recognize and show equivalent fractions have the same size, though not necessarily the same shape. Okay? So this objective is just telling us that we can represent fractions with different pictures, and they'll still be the same fraction. So I have an example right here for you. If you take a look at this picture right here, first off, let's break this down into fraction form. We have 1, 2, 3, 4. 4 is going to be our denominator, and we have one shaded area. So that's going to be our numerator. So 1/4 is what this picture is illustrating for us right now. But the cool thing about this is this is not the only way to represent 1/4. We can do this different ways. We can shade in different areas. I'm going to show you right now. We could come over here and draw it like this and shade this one. Okay? And it still represents 1/4. We have 4 total cubes and 1 is shaded in. Okay? So that's what we're kind of getting at today, is understanding that the fractions can still be the same. The pictures can also be, any way you want in terms of that. As long as your numerator and your denominator match up, you are good to go. So that is still 1/4, and that is 1/4, no matter how you look at it. So we're going to do a couple of examples where we are going to break down a picture that is already drawn for us, and we're going to draw it 2 different ways. Right, so here's our picture to work with right here. The first thing we need to do is understand what fraction we have. So I'm going to draw my line right here. When I'm working with fractions, I like to count the denominator first. That means I like to count all the pieces. All right, all the pieces that make this up. So we have 1, 2, 3, 4, 5, 6, 7. All right, we have 7 pieces here. Now, the numerator represents the highlighted areas, or what's being stressed. So here, we want to count the areas that are shaded. So we have 1, 2, 3. Very good. So this picture here represents 3/7. Okay, 3/7 right here. So our job right now is we're going to draw 2 pictures that show 3/7. So we can put the blocks any which way we want in any order, but the 2 things have to be maintained here. We need 7 total, and 3 of them need to be shaded. So I can come over here and I can do this. So there is 4 right there, 5, 6. There's my 7 blocks right there. And I know that 3 have to be shaded. 1, 2, and 3. And I'm just I know my coloring is not perfect right here. I'm just kind of doing this a little bit faster to show you, but that would be 3 colored in. So let's check it. We have 1, 2, 3, 4, 5, 6, 7. Excellent. We have 3 highlighted, 3/7. Okay? Those represent the same exact fractions, just the picture's a little bit different. Like I said, I can come over here and I can do the same thing here. Okay? And then I can shade anything in I want here. And then just double check it. All right, let's check the denominator. 1, 2, 3, 4, 5, 6, 7. The denominator is correct. And this is telling us we have to have 3 highlighted or 3 shaded areas. 1, 2, 3. That is correct. Okay? So take a look at that right there. That's just showing that we represented the fraction 3/7 in 3 different ways using our cubes. Okay? That's just kind of what I'm kind of looking for you to get the gist of, is understanding that we can do these and solve these problems in different ways. You just have to kind of stick with what the guidelines were, and that was just following that fraction. Now, I want to kind of work on a little misconception here with these next 2 and what they're asking you. This is kind of like a state test kind of question where they're going to make you think here, and I had to really visualize this and practice this a couple times, because you know what, the first time here I didn't really understand what was being asked, but now it makes sense. So these two pictures represent 4/5, okay? 1, 2, 3, 4, 5. We've got 5 cubes here. 4 of them are shaded in. Over here, we have the same thing. We have this rectangle with 4, 1, 2, 3, 4, 5, with 5 pieces, and 4 of them are shaded in, okay? When we come down here, we have a question that's asked, are they equivalent? And I know the first thing you're going to say is, yes, they're 4/5. Yep. And the actual answer to this is no, they are not equivalent. Okay? They're not equivalent because the cubes and the rectangles here are different shapes. Okay? So this one's going to be a lot bigger than the squares here. So when we see that question, are they equivalent? We're going to say no because of the mass and how big they are. Now, if I drew the same picture next to each other, yes, they would be equivalent because they have the same size and they are equal. So just understand that sometimes when they ask if they're equivalent, they might not be because of the size. So here it says, let's draw 2 examples of 4/5. We've been practicing this. This should be very simple. We're going to draw 5 cubes. And we are going to shade 4 of those in. Okay? And then, let's see here. We'll just make it easy on ourselves. We'll just do 5 right there. We'll shade in. Now, like I said, I'm doing this one a little bit quicker so we can get through it. And that one will be 4/5 as well. Okay? So that was Module 5, Lesson 20, and that's just showing you that there's multiple answers for fractions, that, again, I've been stressing this in all the lessons here. Take your time. Understand what is being asked of you in terms of the follow-up questions, and you should be fine. Head over to the exit ticket. I got some fractions for you to practice, looking for equivalent and non-equivalent, and also maybe building some more pictures in terms of fraction examples. I will see you guys tomorrow, and I will get that feedback right back to you. Have a great day.